Hi, everybody. My name is Perry Correll, and I'm a director of product marketing at Extreme. And for the next few minutes, we're going to kind of talk about what's new in enterprise wireless. And let's just be honest. These days, you hear Wi-Fi, you hear 5G, you hear CBRS, you hear Zigbee, Z-Wave, Thread, 802.15, ultra wideband, and others. Well, today we're going to kind of focus on the top three. We're going to focus on Wi-Fi, we're going to focus on 5G, and we're going to focus on CBRS a little. So let's get started. So, when you talk a lot about 5G and when you talk a lot about Wi-Fi, especially Wi-Fi 6, people say, where are we today? What's going on with this stuff and that functionality? What's kind of important to realize is they actually both came out of the same place. If you kind of go back a few years, back to 2012, the ITU, the International Telecommunications Union, they created this thing called IMT 2020, International Mobile Telecommunication 2020, essentially what the world's supposed to look like in 2020, that more users, more applications, more computer, higher bandwidth, all the things, everything everybody dreams about as far as wireless communication. And what's funny is both the unlicensed and licensed development came out of there. So if you kind of look at where, Wi-Fi 11AX, Wi-Fi 6 came from, it came out of this. If you look at 5G, it also came out of that. So that being said, let's kind of get started. Let's talk about Wi-Fi and the evolution of Wi-Fi. So whether we're talking about Wi-Fi or even when we're talking about 5G a little bit later on, or cellular communication, it's a continual evolution. We go back, Wi-Fi goes back to 1997, so it's a pretty mature technology. But about every 18, 24 months, there's a new technology that comes out. So first you had 802.11, then A, B, G, N, N 150, N300, N450, 11AC Wave 1, 11AC Wave 2, and now 11AX. So it's kind of interesting to see what's actually happening with the Wi-Fi technology. And now we're actually even talking about a newer one. We're actually talking about 6E, which you're going to hear a lot more about in the coming months. And there's also, kind of jumped ahead there a little bit, there's also Wi-Fi 7 on the horizon. So once again, be aware that whatever technology you're looking at, there's always something new coming along. And why I mention that is, there's a lot of people that look at Wi-Fi and go, well, maybe I'll wait for the next release. You're never going to get there because there's always going to be something new coming along. And as you can see, the different technologies, the different bands, the different functionalities, and Wi-Fi 7, 802.11be, they're already working on that, even though, Wi-Fi 6 is just coming out, 6E is coming out, and that type of functionality. So it's important to understand that and important to appreciate that going forward. So where are we today? Today we're at Wi-Fi 6. And what's Wi-Fi 6 all about? One of the problems with Wi-Fi and one of the problems with us as a vendor is that about every 18 or 24 months, we'll come and talk to our customers, we'll come and talk to our partners, and we'll say, hey, I got this brand new technology going to solve all your problems, going to make life easy for you on the wireless space. And after so many times, people just don't believe you anymore. And so when I come out and I say Wi-Fi 6 is different, they say, yeah, you're a marketing guy. Should I believe that? You really need to believe it. And because we created this problem for ourselves. But Wi-Fi 6 is totally different because with Wi-Fi 6, you had a bunch of new technologies. You hear QAM and you hear TWT and you call multi-user MIMO and OBSS and all this good stuff out there. But the most important part of Wi-Fi 6 is something called OFDMA, orthogonal frequency division multiple access. Now you say that enough, you sound pretty smart, but you don't really have to worry about what it is. But what it actually does is it allows simultaneous communication of devices. And that's the key differentiator, because it's very important to realize that up till now, every previous technology of Wi-Fi, even though you might have 10, 100, 200 devices connected on that one radio, only one of those devices could talk at a time. The others have to contend. The others have to wait. The others have to apply QoS. And with 11AX, with the Wi-Fi 6, and by the way, 802.11ax, that's the IEEE standard. Wi-Fi 6, that's the Wi-Fi Alliance certification program. So they kind of, very similar as far as what they are. So understand they kind of, you can use those terms interchangeably. But with this technology, it actually is different. It really is important to understand that. The other thing to appreciate about Wi-Fi 6, 11AX, is a lot of times when a new technology comes along, the customer's going, well, I don't know. I don't want to get onto the bleeding edge of technology. I might wait a few years before I actually get involved with this. Be aware that most of the technology, if not all the technology involved with Wi-Fi 6 is actually coming, or a lot of it's coming from other technologies, especially OFDMA. OFDMA has been on the cellular side of the house, the licensed side of the house, since 2007. So it's important to understand it's not brand new. So as I was mentioning before, The older technologies were a little bit different. And as you can see in this slide, the way it actually works is that if I go back here, if I look at the way Wi-Fi used to work, I would talk to one client, and then I'd talk to the next client, and then I'd talk to the next client, and then I'd talk to the next client. And this is the way previous technologies work, all the way through the alphabet soup of A, B, G, N, and AC. And what the different technologies did up to this point was they just went faster and faster and faster, and that's all they did. Well, what happened with 11ax is it got a little bit different. What happened with 11ax is we used something, OFDMA, and we created these things called resource units. Because you see, with a Wi-Fi channel, let's just say a 20 megahertz channel, it's not one channel. It's actually dozens, hundreds of different channels. And the way the older technologies work is that one device would use all of that channel at a time. What OFDMA did, what 11ax does, is I break up that channel. So I can actually have 9 users on the top row with small amount of bandwidth talking simultaneously. Or I can have 4 users, or I can have 2 users, or I can have 1 user, or I can mix it any way I want. And that's very, very important to understand and appreciate that I can mix any way I want. So one transmit opportunity, like right now, I can give all the bandwidth to one device. Maybe they just need a lot of traffic. But the next transmit opportunity, I can split it up anyway between 1 and 9 different devices. And that's just in a 20 megahertz channel. If I'm using 40 megahertz or 80 megahertz, I can actually get more channels out of that. So it's very important to understand the difference between this technology. And as I said, we kind of hurt ourselves in the past by every 2 years saying it's newer and better. This actually is. And if you look at it in some ways, there are some people that actually say that, it's almost like Wi-Fi switching. Now, the techies get all upset about that when you use that switching word. But the thing is, I can talk to multiple devices simultaneously. And that's really, really important because let's say I'm in a hospital environment or critical care environment type stuff, and I've got very, very important equipment. Which one gets prioritized over the other? If I could talk to both of them at the same time, obviously there's a tremendous advantage of that. So looking at this slightly different is this is the way it works. I got the channel width and I've got these subcarriers. And the first time I talk, I'll talk to 2 different devices. Second time I talk, I might be talking to 4 devices. Third opportunity, I give all the bandwidth to one person. And by the way, it's the AP making this decision. So when the AP has a bunch of traffic, it decides who's going to get that traffic, who's going to talk simultaneously, and who's going to have to wait. It also does that on the upstream. So be aware, this is downstream and upstream. So on the next opportunity, I might split it up between 2 clients. The next opportunity, everything goes to 1 again. And finally, maybe I'll split it up between 3 different people. How I split this up and when I split this up is really going to be dependent on the amount of bandwidth the client has to send, what type of traffic they're sending. Obviously, if it's just email, it can wait a little bit. If it's a real-time voice or some critical, or if I just higher priority, I want to give the boss higher priority over everything else. So obviously, it's a tremendous value and very, very useful that way. So if we want to look at this a different way, this is that same picture I had before, but now we're going to look at it with how it works with OFDMA. Obviously, that's why OFDMA, that's why Wi-Fi 6, that's why 11ax is defined as more efficient. Yeah, it's a little bit faster and all that, but the key value is it's more efficient. I get to talk to 5, 10, 15, 20 different devices simultaneously, and those values will change depending on how you're using this. So once again, it's very, very important to understand, very, very important to appreciate that Wi-Fi 6 is actually different. And this is kind of gives you an idea, a little bit of an eye chart that you can kind of, pause and take a look at it right now if you want. The biggest difference is over on the right. Obviously, you get a lot more bandwidth coming along with 6E. Once again, 6E is down the road. It's not even certified yet. It's not even standardized yet. It's on the road. And as I said, the right column over there, you're going to see Wi-Fi 7 in the not too different future. But it kind of gives you an idea what's happening and the different technologies out there. So once again, take advantage of it. Be aware of what's going on out there. Okay, so the next one I want to talk about is 5G. And by the way, I've got to let you know that if you're talking to somebody and they're saying 5G is going to replace Wi-Fi, walk away because they don't know what they're talking about. If you talk to any of the major organizations, the Wi-Fi Alliance, the Wireless Broadband Alliance, anybody who's, I hate to say educated, they realize that both 5G and Wi-Fi is going to coexist for the rest of our lives. And if you don't think that, think about it in a numbers game. Right now, there's approximately 13 to 15 billion Wi-Fi devices out there. pick the number you want. It's very, very high, whichever it is. Right. A recent prediction says that within the next 5 years, you'll have 1.5 billion 5G devices. So obviously the numbers just don't match. So your cell phone, if it doesn't support 5G now, it'll probably in the next release, but your tablet, your laptop, do those have, cellular uplinks? They don't. The printer in your house, the printer in your office probably doesn't. Your smart TV probably doesn't. So Wi-Fi is always going to be there. But once again, back to 5G. 5G came out of IMT 2020, just like 11AX did, really designed to be much, much faster, support billions of devices, extremely low latency, reduction in network usage. Low latency is probably the key point in there because they're targeting 1 millisecond latency. Obviously, that's probably not going to happen except in a very controlled testing environment, but be aware that's what kind of they're looking for. Wi-Fi, once again, 5G, lots of different technologies. And be aware also that just because you've got multiple carriers that they say they support 5G, it doesn't mean they support the same functionalities. 5G has a lot of different components to it. And what happens as soon as a carrier, as soon as a vendor or somebody has one of those capabilities, they say we're 5G compliant. So be aware that not all 5G is the same, not all 5G is equal. Also, 5G has actually got two major parts. You got 5G NR, which is new radio, and 5G time slicing. What new radio is all about is using more bands, the low band, below 1 gigahertz, the mid band, 1 to 6 gigahertz, and the high band, obviously anything above 6 gigahertz, 24, 48 is what they're talking about. But the idea about 5G is I want to use it all. I want to have all these wireless bands as access point into a 5G network. And that actually includes Wi-Fi. So you can have licensed spectrum, you're going to have shared spectrum, and you can have unlicensed spectrum. So once again, licensed spectrum, your typical cellular, unlicensed spectrum would be Wi-Fi, and shared spectrum would be like CBRS. The other part of this is network slicing, the ability to actually separate segments of the network. And each one of these segments, depending on the use case, will get different QoS, different compute power, different resource power, different latency requirements. So it gives you, once again, not a lot of people are talking about this, but it's extremely valuable going forward. So once again, the two big parts of 5G are the new radio and the network slicing component. The next one I want to talk about is CBRS. CBRS is Consumer Band Radio Services. It's not the CB stuff that Smokey and the Bandit used back in the 70s. But what this is, and actually it's about 150 megahertz worth of spectrum in North America. There's some other spectrum internationally. And it's really kind of designed as a shared spectrum. Let me give you a great use case. Let's say you got your favorite restaurant and you go in there and the cellular is terrible there and they don't have Wi-Fi. You don't get anything. And if that restaurant, they went to the local carrier and said, hey, we need better coverage. You want to add another tower? It's never going to happen. But if they put in CBRS, it's essentially like an access point. They put it up there, and what you're doing is I'm putting LTE type technology. I'm putting, basically licensed cellular radios type inside my business. And then if I have a phone that actually supports CBRS technology, then once again, seamless roaming inside. Once the FCC is dealing with it, we just had a great big auction and a tremendous amount of interest in there. So you might see a little bit coming more in the next coming months. The components of it is that we're actually 3 different levels. As I said, there's only about 150 megahertz worth of spectrum. About the top 50 of that is owned by incumbents. It's Department of Defense, maybe some satellite uplink type functionality. Then you've got kind of the licensed area, what was just done, what's called PAL, PAA, Priority Access Licensing, and you get to auction for that, so you can buy it. And then what's left over is general availability. It's, you can kind of do what you want with that functionality. The other part of this is on the right there. It says Spectrum Access System. What this means is I've got to connect to this to make sure that the channels I want to use, the bands I want to use, are available to me to use. So once again, it's very, very important to understand it's going to have a place, it's going to fit in. So that being said, how does this all come together? I'll give you a secret. There's no perfect wireless technology for all use cases. Cellular, 5G, Wi-Fi, Wi-Fi 6, CBRS, they all have unique use cases. They all have unique values. They will all fit in different areas. One technology is probably never going to replace the other. So I'm not going to rip out all my Wi-Fi to put in CBRS or private LTE. I'm not going to replace all my cellular towers with Wi-Fi towers. They're going to work in conjunction with each other. And there is such a thing as good enough. And that's one of the views that can 5G, can CBRS add some functionality, some performance that improves over Wi-Fi? Yes, it can. But does my application demand that? Maybe not enough. And as a result, a lot of IT administrators, a lot of people say, I'd rather manage one network than actually 3 networks or 2 networks. So a lot of times, obviously the Wi-Fi is good enough. You'll have some 5G for uplink and maybe CBRS where it needs. That's the future, and that's what we're dealing with. And who knows what wireless technology comes along next? To be honest, if I knew more, I would invest better. So hopefully this helps out, gives you a little bit of information. Reach out to myself or reach out to Extreme if you need a little bit more. Thank you very much and have a great day.